So we're going to look at solving linear equations, and basically for years 9 and most of year 10, that's the only sort of equations you get. So solving is the process of finding the value of an unknown by rearranging our equation. And that's done in a series of steps, each of which make the equation simpler. And our rule is what we do to one side, we must do to the other to make it stay equal. In one step example, we do one thing to get rid of the number between us and knowing the value of the unknown. So in this case, we have x plus 3 equals 8. We want to find the value of x. So I need to get rid of the 3. Well, the way to get rid of the 3 is to take it away. I can't take it away on one side of the equation without taking it away from the other side. So that's what I do. I take the 3 away from both sides of the equation. Having taken it away from the left hand side, I'm left with x, and 8 minus 3 is 5. That's the procedure basically complete, and now we just have to apply it to the other operations. So let's do it again. This time I know that x minus 7 is equal to 21. I want to know what x is. I need to get rid of the minus 7. Well, the opposite of minus 7 is adding. So if I add 7 to the left, I'll get rid of the minus 7, which means I need to add 7 to the right to keep the equation balanced. That gives me the x on the left hand side, which is what I wanted. The minus 7 has been removed, and on the right, to replace it, we now have 28. Okay, next to the simple cases, I have 3 lots of x equal to 18. Well, I want to know what one lot of x is, so I divide out the times 3. I've done it on one side, I must do it on the other side, and that tells me that x is equal to 6, because 18 divided by 3 is equal to 6. And those 3 equations there are basically all you need at year 9, and they are the same steps that we take into year 10. It's just that we do 1 or 2 more of them in each equation. So let's work through some again. Here we have 5 plus x is equal to 2. I want what x is equal to. I need to get rid of that 5 because I want to know x is equal to, not 5 plus x is equal to. I take it away from the left, which means I take it away from the right. X is equal to minus 3. Well, there's no problem with it being a negative number. That just happens to be the answer to the equation. I've had a plus on the left. I want to get rid of it. I take it away. I take it away from the other side. 2 minus 5 is minus 3. Let's do another one. K minus 0.5 is equal to 2. Well, I want to know what k is. I add 0.5 to both sides of the equation. That gets rid of it on the left, and I'm left with k, and the right is 2 plus 0.5, which is 2.5. And multiplication. I know that 7 x's are 16. I want to know what 1x is. So I divide by 7. In this case, 16 divided by 7 is kind of awkward. It's not a whole number. So what I'll actually do is I'll choose to do it as a fraction. So we'll do them as fractions. I'll have 7 divided by 7 is 1, so that cancels on the left hand side, and my answer is 16 over 7. One last time through for the slightly harder case, which is the division. To get rid of a division, I want to multiply by the left hand side, which means I multiply by the right hand side, and so I get x is equal to 10. There we have it. We have either an addition, subtraction, multiplication, or division. We use the opposite procedure to both sides to find the value of our unknown. So we solve by doing the opposite to both sides to remove the operation. We subtract to remove an addition, add to remove a subtraction, divide to get rid of a multiplication, and multiplied to get rid of a division.